Assalamualaikum and a very good day to all of you. So now we will continue our class, right? For the next part of construction noise management. Okay, we are still in week 13, right? So we are going to cover the next part, which is part 3 on construction noise monitoring, measurement and abatement, right? So as usual, this is our quick check or tracking for our previous topics or subtopics. Here we have settled these two, part 1 and part 2, construction issues and management as an overview for the whole topic. And then we continue last night with construction noise propagation, covering all characteristic of noise, type of noise, and all the description related to the noise propagation. Okay, so as for now, we will continue on the third part, which is on construction noise monitoring, measurement and abatement. Before we conclude or we proceed with our last part for the calculation, right? Focusing on noise prediction. Okay, so basically this is our third part lah, third part for the topic. This one dia lebih kepada noise monitoring and how we want to conduct the noise measurement to measure construction noise. Okay. Similarly for the assessment. Assessment pun saya akan upload later on. Saya akan inform lah the details regarding the question and for the grouping through WhatsApp group and also e-learning, okay, as the platform. Alright. So untuk dua part yang pertama, for the first two parts, okay kan semua? So kalau ada apa-apa yang tak clear, okay, anything to verify ke apa, kita boleh discuss lah. So kalau later on ada nak tanya ke apa, boleh je. Right? So for next part, which is part 3, this is several outlines regarding the subtopics or subcontents. Okay, first of all, kita kena tahulah apa dia punya purpose or aim of the construction noise measurement. Why we conduct the construction noise management in terms of its purpose or objective, right? And related to the construction noise monitoring and measurement, we for sure need the related instrumentation ataupun equipment lah. Equipment apa yang selalunya diguna pakai untuk measure the construction noise. In our case lah, we are focusing on construction noise, right? So proceed with this one. We will briefly cover on noise level measurement and then assessment. At the end, saya akan share juga berkenaan sound level databases. Maksudnya existing and available databases related to the sound level for each plant and machineries. Okay. So far okay semua?
Okay.
Right. Okay. The next one. Okay. So as I mentioned just now, we need to know the purpose for construction noise measurement. Why we need to conduct construction noise measurement. Okay. So in overall, the main purpose of noise measurement is to determine the background noise level. So nanti kita akan tengok juga background noise level ni in our calculation. So sometimes background noise level ni kita refer dia sebagai ambient ataupun ni lah dia punya bunyi apa, latar belakang lah, maksudnya existing ambient noise level. So we need to know the existing ambient or background noise level for specific location lah yang kita fokus to proceed with the detailed noise measurement. Okay, and then noise measurement ni juga why we need to conduct the monitoring, we need to conduct the measurement because we would like to obtain information of noise from the equipment, okay, individual equipment or plant and machineries on site. Okay, sebab tu kita perlu conduct noise measurement. Selalunya untuk noise measurement for each individual equipment, kita akan conduct sebelum ni lah based on dia punya guidelines dan juga based on actual practice atau experience. Okay, if we let's say kita ada satu equipment, excavator ataupun tak kisahlah, any related plant and machineries on site, so kita kena right. Okay, so in terms of measurement, kita perlu measure in terms of dia punya receiver point ataupun measurement point is within 1 meter. Okay, 1 meter daripada alat tu ataupun plant and machinery tu. So that's for the measurement of individual construction noise and machineries. Okay. And based on the measurement juga, kita boleh obtain any information related to the construction noise level itself. Maksudnya, Arif boleh ke mute? Ya. Saya boleh.
Sorry.
Alright, okay. Okay, so tadi kita dah tengok apa measurement on noise equipment. Saya dah explain berkenaan individual noise measurement for each construction plant and machineries. So supposed to be kita conduct the measurement within 1 meter from the individual machineries itself. And then for the construction noise level, it depending because the distance can be varies because later on we can do the conversion. Okay, so kebiasaannya kita akan measure at distance of 10 meter. Okay, the available database pun they provide the information of equivalent continuous sound pressure level at 10 meter distance. Okay, so nanti saya akan share juga berkenaan existing databases for each of the individual equipment. And as well as a noise from other sources. So kita kena take note lah if the construction site located to the busy traffic condition, so kita kena take note of that. And then that one also will be recorded in the measurement, alright. And the other thing is that this measured noise level, the main purpose is that to determine the anticipated community response and impact of noise. So basically based on the measurement of noise level, yang paling utama that we want to evaluate, that we want to identify is this one. We need to determine the expected or anticipated community response and impact of the noise. So that's why all of these are required in the EIE, Environmental Impact Assessment. So that kita dah boleh predict and kita boleh forecast the potential response by the nearby community or nearby residents and apa dia punya potential impact of the noise. Is it severe, is it acceptable and so on. So nanti kita tengok that part, right? Okay. Okay, for the measurement, this is several instrumentations. Okay, basically this is the main instrument that required to capture or to record the noise level. So saya maybe I'm sure that maybe some of you already aware regarding this one. Most of you ataupun semua yang memang dah tahu. So kita menggunakan sound level meter to capture the sound or to record the sound. Okay, so that we can measure the noise level or sound level, right? So this is the main instrumentation. Okay. So I think most of us memang dah tahu, cuma in terms of dia punya detail description, in terms of dia punya jenis, so I would like to share lah regarding that. Okay. Yeah, apa orang panggil, in market ataupun existing market lah, yang kat luar sana, there are two types of sound level meter which are available, such as type 1 and type 2. So this type are the main category ataupun jenis lah for the sound level meter itself, for the purpose of construction noise measurement ataupun the other type of noise measurement, contohnya traffic noise measurement, occupational noise measurement, and so on. Okay, so we need this instrument. Alright, yang penting kat sini, we need to know the difference between these two types. Okay, so type 1, jenis yang pertama, the main difference ataupun apa yang menyebabkan beza dengan type 2 adalah in terms of its accuracy. Okay, kalau type 1 dia punya apa panggil, reading error is plus minus 1 decibel only. Okay, as compared to type 2, because type 2 is plus minus 2 decibel. So this is the main the main difference, and kenapa kita refer dia sebagai type 1 and type 2. Okay, so basically it is related to the accuracy value. Okay, satu, and then the other difference is that dia relates kepada types of the parameter ataupun types of the measurement that being captured by each of these instrument. Okay, for example, type 1 dia macam satu alat yang very comprehensive. It provide a detailed information. Okay, for example, type 1, this one one model lah, hanya model dia pulsar. Okay, kalau nak tengok, kita boleh tengok juga and this one available in our lab. Okay, so for the actual measurement, saya sendiri dan the rest of the person in charge memang menggunakan alat ni. Okay, so pulsar is one of the model for type 1 sound level meter. Okay, so for this one, for this model, kalau kita refer, dia punya type 1 consists of several modes ataupun several parts for the measurement. So kita either can use sound level meter punya mode, and then the other two we have measurement for frequency. Okay, as I mentioned last night or in our previous class, there are two main frequency types or frequency band that we use for the measurement purpose, such as frequency octave 1 and the other one is 1/3 octave. Ataupun selalunya kita refer dia sebagai 1/3 octave band. So dekat alat ni, sound level meter type 1 ni, dia able to measure in terms of both sound level and also frequency mode. Frequency dia ada dua lah, as I mentioned, 1 octave and 1/3 octave. Okay, so 1 octave and also 1/3. So nanti once saya dah share all the notes, boleh refer balik lah sebenarnya apa this octave ni refers to. Okay, so dia punya ability ataupun capability of this type 1 differ from type 2. Sebab dekat type 2 selalunya dia only able to measure ataupun to store data on sound level only. So dia tak ada frequency punya measurement, dia tak ada frequency punya values to be recorded in the data logger or instrument itself. Okay, so that's the main difference in terms of its accuracy and also in terms of its capability to measure the certain or required information lah. So that's why type 1 punya sound level meter dia lagi comprehensive. Okay, Alright, so far, ada ke anyone pernah operate ataupun pernah handle sound level meter? Ada? Ada ke? Pernah masuk, kalau tak pernah operate pun maybe pernah macam ni, pernah tahu tu, ada ke?
Macam tak ada dok.
Tak ada.
Saya tak terlibat dengan public kan.
Oh, sekejap. Arif, kerja kat mana?
Banyak
Kerja apa?
buat infrastructure.
Oh, tak.
Logi air.
Oh, okay.
Air reservoir semata bukit. Pengambulian je.
Alright. So tak ada building punya lah.
Tak ada guna ni.
Tak apa. It's okay. Thank you Right, so it's okay kalau tak pernah handle corporate. So at least I hope that this subject ataupun this class will provide additional knowledge lah ataupun additional exposure to how we manage and we monitor the noise management, noise construction noise. Okay, I think that's all for the sound level meter, which is the main instrument for construction noise measurement. And then we have the other instrument. Okay, this is basically the description for the previous yang saya dah mention just now. So both type 1 and type 2 accepted by DOE, Department of Environment, for noise monitoring and measurement purposes. So as long as we are able to provide information in terms of sound level values, okay, sound level for each proposed location, and then to kira dah sufficient lah in terms of the information. Selalunya type 1 tadi dia lebih kepada research purpose or detailed study regarding the sound and noise management. Okay, so as long as kalau kita dah ada type itu pun dah dikira quite okay. Sebab dia dah boleh serve ataupun dia dah boleh provide the required information. Okay, in terms of sebab kalau kita tengok the difference between type 1 and type 2 quite dia punya capability type 1 much more better than type 2, so for sure dia punya harga pun akan berbeza lah. Type 2 much cheaper than type 1. Okay, ni macam saya dah mention just now, SLM sound level meter type 1 able to show this one, sound pressure level, and then octave band 1 octave, and 1/3. Dia punya ability sebab dia lagi detail. And then type 2 only measure the sound pressure level. Okay, that's the difference. Okay, continue to on how we want to use how we set up the instrumentation atau sound level meter. Kebanyakan sound level meter ni dia come with the outdoor weatherproof kit. Okay, maksudnya this one set up untuk terkendak outdoor measurement, noise measurement. So weatherproof kit ni adalah lightweight outdoor weatherproof system. Is used to measure on-site construction noise emission levels. Okay, so kalau kita tengok kat sini, this is example based on my previous assessment of noise management, noise monitoring on-site. If I'm not mistaken, this one is building office building, double story office building here. Okay, so yang ni kalau refer balik to this figure, so basically this black box ni, kotak hitam ni adalah weatherproof kit. Okay, alat main structure dia adalah sound level meter kan. And then if we are doing outdoor measurement, selalunya especially for the masa yang panjang, for example 8 hours working duration, so we are suggested to use this weatherproof kit. Okay, so kalau setup dia, tengok kat sini, ni adalah dia punya microphone. The microphone ni will be disattached lah, kita akan cabut daripada dia punya main body, and then ada cable connecting to this box. Okay, so dia punya the rest of the main body ataupun main structure of the equipment will be stored in this box. Okay, yang ni. So maksudnya dia punya bahagian atas ni je yang akan attach ataupun akan kita akan pasang kat luar, and then half main body dia ni kita akan store kat dalam kotak je lah. So kabel ni yang akan connect. Okay, this one in terms of the house, in terms of the setting of the equipment. Okay, and then kalau untuk pulsar punya model ni, dia rasanya dia punya kabel about 10 meter. So kita boleh letak set up alat ni dekat this point ataupun kita punya measurement point lah, and then kita boleh store this weatherproof kit box ni within 10 meters away. So kalau kita ada tempat yang tempat menunggu ataupun tempat kita rehat tu, and then kita boleh bawa lah sekali sebab dia punya kabel quite panjang juga for the purpose of powder monitoring. Okay, so according to the guidelines by the OE, kita punya setting microphone level to the ground level should be within this range lah, 1.2 to 1.5 meter above the ground level. Okay, so this is the best requirement as stated in the guidelines by the OE. Okay, some more regarding the sound level meter. As I mentioned just now, type 1 is more comprehensive ataupun dia lagi detail as compared to type 2. So basically type 1 dia come together with the data logger. Dia ada dia punya own software to store the data. Okay. For example, still we take it pulsar sound level meter model. So ini adalah dia punya interface for the software. Once we have set up the equipment, kita dah calibrate everything, kita dah set up and ready for the measurement, and then we need to register the respected reading with different registration number. So dalam alat tu dia dah ada dia punya data logging, and how we want to trace back the data, kita tengok kepada registration number RN. Okay, so bila kat site kita dah take note which registration number. So once we have completed the measurement, we can refer back to this data logging with specific registration number. Then kita boleh extract the data and transfer to the our own PC or computer, right? For detailed analysis. So based on the extraction of the data, we are able to obtain this detailed information. Okay, so kita dah tengok sini dia dah automatically develop ataupun come out with this chart. Okay, put according to our measurement duration lah. Kalau yang ni 8 hours, so dia akan display all the data for this measurement period. Okay, alright. So that's for sound level meter. It's one of the important ataupun main equipment that we need for the noise measurement. Alright. Okay. So continue to that, another instrument ataupun dia dah memang come together adalah calibrator. So we need to always remember that any equipment or any device instrumentation should be calibrated. Okay, so that kita akan avoid the reading error, kita akan avoid any error for the instrument to capture the actual data, right? So for the purpose of noise measurement, we should calibrate the sound level meter before and after measurement. Okay, so that dia punya reading always in a good apa panggil, dia akan produce a good reading, and each model supposed to have its own calibrator. Okay, we need to use the right calibrator for each instrument. And then the main purpose ataupun kenapa kita perlu calibrate juga adalah berkenaan to quickly check the accuracy of the sound level meter in terms of the condition. Jadi, kalau ada reading error yang terlalu besar, and then it represent that the equipment is not fit for the measurement. So that's why kita kena check lah before and after measurement. Adakah that instrument is ready to be used for the measurement. So for the type 1, dia punya reference sound should be 94 dB plus minus 1. Okay, so maksudnya kalau kita calibrate the equipment, this is the calibration value for the 94. So plus minus 1, it should be within this range, 93 to 95. So kita kena make sure kalau once dah calibrate, tiba-tiba the equipment yang kita nak guna tu recorded calibrated value for 90 for example, or 60 something. So kita kena double check on this reading, kita cuba recalibrate. Kalau ada masih lagi dia punya margin difference tu quite tinggi, dengan sepatut 93 ke 95, however the actual calibrated value is about 80 something. So alat tu ada dia punya rosak kat mana-mana. So that one suddenly kita akan refer back to the consultant ataupun to the supplier. Okay. And then ni yang saya dah mention, accepted calibration readings before and after. Okay, that one for the first one sound level meter, and then the second one for its calibrator. Okay. Most of the time, for the purpose of noise monitoring and also construction noise management, we need this distometer. Sebab distometer is another instrument that replace the conventional measuring tape. Okay. By using the distometer, kita boleh measure distance between receivers and sources. So sebab kalau kita guna measuring tape yang biasa tu, it's quite difficult for us sebab selalunya kita punya distance from both side to the nearby resident susah lah kita measure. So that's why we need to use distometer or laser distometer. So we just tembak the laser punya ni, jadi kita tahulah dia punya distance between receivers and sources. And then ada distance such as receiver dengan angle reflecting surface, any obstacles, okay, ketinggian sound level meter dengan ground level, and dia punya ketinggian sources itu sendiri. Okay, so in terms of dimensioning, height, distance, length, semua kita akan menggunakan distometer. And in terms of accuracy, dia punya measuring accuracy is usually within 1 millimeter, okay, and maximum range of distance about 200 meter, okay. So that's basically this is the description ataupun dia punya information for the distometer itself, okay. And it can be used indoor and outdoor. Okay. Kalau kita nak measure dimensioning in room ataupun any classroom ke lecture hall ke, kita boleh menggunakan the same instrument. Okay. Kita boleh just simply on the instrument and then menggunakan dia punya ni lah, laser instrumental. Alright. So far okay eh?
Okay, doktor.
Okey, doktor.
Okay eh? So harapnya clear lah. Okay, apart from tadi kita dah ada sound level meter, its calibrator and this meter, we have another one which is anemometer. Another required instrumentation for the noise measurement. So basically anemometer most of the time kita akan guna dia for the outdoor noise measurement. Okay, for our case, we need this because we are measuring, we are covering on construction noise, which is outdoor. Okay, so anemometer ni dia punya kegunaan more on measurement of meteorological condition, okay, including wind speeds, temperature, air temperature. Okay, so that's why we need to use this anemometer. Kita kena tahu wind speed, lepas tu air temperature, okay, because wind speed ataupun air temperature ni part of the factor that might affect the noise level. Okay, that one has been outlined in ISO, okay, so we need to follow that. Kita kena tahu sebab in our longer scope, okay lagi lah, kalau angin tu tak terlalu kuat, so okay, tapi in case of situation tiba angin kuat dan temperature is very high, macam dia punya limit wind speed saya rasa should be less than 2.5, okay, 0.5 meter per second. And then this one saya kena double check balik dia punya air temperature. Okay, so as long as kebiasaannya kalau based on saya punya experience pun the apa panggil this reading both wind speed and air temperature are still within the allowable limit ataupun allowable range. Okay, so kalau terlalu kuat sangat angin, that one will affect the reading. So it's very essential lah for us to include this measurement part of the noise monitoring. Okay, so as I mentioned, anemometer measures temperature, the surrounding temperature, air temperature, and wind speed at the height of sound level, the microphone. So just now kalau kita tengok balik dekat microphone setup tadi, this is tripod, this is the microphone. So kena ambil dekat ni lah level ni, same level with this mic. So anemometer should be hold at the same level or height with the sound level with this microphone. Okay, that's all for the required instrumentation. Okay, this is the example. This one for anemometer, wind probe. Kita boleh tahu dia punya air temperature and wind speed. And this one is one type of distimeter, right? Okay. So in terms of noise level measurement, macam mana ataupun dia punya requirement that we need to know for us to conduct the measurement. Okay, so it's basically categorized or classified into two stages. First one, prior to construction activities, maksudnya sebelum construction to start, especially during the planning stage. And then the other one during the construction as part of the monitoring purpose. Okay, so untuk the first stage, which is we call during the planning stage. Okay, this is the sub requirement for the noise measurement. Okay, kita kena measure the noise at several receiver position. Saya akan tunjuk juga dia punya gambar, okay, which consists of boundary. So kita duduk dekat boundary in between the nearby, we call nearby residential premises with the proposed site, and then at the residence point, okay, receiver point, and dia punya inilah activities, daily activities. Lepas tu kita perlu juga measure dia punya ambient or background noise level. Okay. Yang ni saya dah mention juga in terms of the indices. This one background noise ni adalah L90. Okay. Which represent the noise level atau sound level for 90% of the measurement time. So that's why kita call it as L90 here. Right. And then we have this established value for L90 based on the combination all of these measurement. So this one for the first stage of first type prior to construction, which is during the planning stage, and then during the construction stage, it's more on we conduct mass measurement for monitoring purposes. Okay, kena measure adakah the current ataupun existing punya noise level is still comply with the permissible noise limit. Okay, so nanti saya tunjuk dia punya ni. Kalau untuk during the construction, kita boleh measure dulu lah. Jadi saya dah mention just now, kita ada construction operation and then individual equipment. Okay, so kita tengok kat sini. 1 meter and 10 meter both boleh apply. Okay, kalau receiver position varies depending on the nearby location ataupun nearby point. And then construction operation can be divided into two, particular and multiple. So particular ni lebih pada individual. And then most of the time kita akan ada multiple operation lah. So maksudnya earthwork maybe gerak ataupun maybe constructed concurrently with the piling depending on the scope of work and stages of the construction. So based on its own plan and scheduling. Okay, planning and scheduling. Alright, so these are several types of construction stages starting from demolition, kalau dia require demolition, up until external works. Okay, so this is some example of the construction stages. Okay, kalau kita tengok untuk individual equipment pula, it's mostly being measured to be included in the database. Maksudnya the respected party or respected department would like to update their database on some power of each individual construction plan and machineries. And for sure they also want to include it in the standard, right? So that's regarding the noise level measurement types of category. Next one, still related with description lah. Kalau ikut saya dah mention juga, okay, prior to construction, kita nak evaluate existing levels. Okay, just now kita dah tengok L90. Okay, yang ni as I mentioned, dia ada at least 3 selected receiver, di boundary first, and then resident. Boundary dekat dia punya ni lah, boundary, property boundary, and the resident ni residential unit, and position closest to human activity. Maksudnya human activity ni can be, for example, dekat residential tu ada taman ataupun any recreational park. So kita boleh cuba measure dekat that position. And in terms of the measurement, most of the time kita akan guna fast mode atau fast time with A-weighted. So that's why last night, last malam, kita dah cover berkenaan LEM. Okay, maksudnya some pressure level with A-weighted and fast response, fast time move response. So LEM ataupun LAQ. Okay, LAQI sedikit banyak dia punya ni. Okay. Tapi dia refer to the same thing lah, to the same nilai. And establish background noise ni sangat penting sebab dia dah jadi benchmark untuk reading ataupun dia punya values in terms of LEQ ataupun L10 nanti untuk future construction. Okay. sama juga relates to the first stage of the noise level measurement prior to construction. Dia focusing on the background noise level itself. Dia maksudnya dia dah measure, dia tahu the information of the sound level or noise level for the ambient surrounding. So dia dah tahu based on various sources, okay, macam apa existing neighborhood activities plus nearby traffic noise. So that one will be contribute as background noise level. Okay. And kalau yang ni maksudnya only noise which typically occurs during the time period for which construction noise is evaluated. Maksudnya any noise yang happen at the same time with the construction noise progress or construction activities progress will be evaluated. Okay, so sebab kalau kita tahu dekat environment, okay, outdoor environment or ambient noise level, dia mix of several sources of noise, tapi kita fokus on noise sources that happens frequently during the construction activities. Okay, so ni yang saya dah mention which point or which receiver point that we need to measure kalau kita conduct the planning stage for the measurement. Okay, satu boundary, so boundary between the proposed site and nearby community and the resident. Okay, maksudnya each resident point as a receiver, and then human activity. Kalau ini dekat taman, okay, nearby or close to the construction site. Okay. Next stage during the construction, similarly, just now I already mentioned some of these sub-content or description. Using the same receiver point, kita reconduct the measurement once the construction start. Okay, so kita boleh tengoklah dia punya increment ataupun dia punya effect before and during the construction. So in terms of the monitoring, we can monitor the current or the latest noise level. Okay. And sama juga kalau during the construction, the same setup for the sound level meter, which is using LAF, using the fast response and also A-window. Okay. Just repeat the same procedure. Kita measure juga the temperature and speed. Okay, sama juga. Cuma dia punya tempoh waktu je lah, dia punya tempoh masa je. The first one prior to the construction, which is during the planning stage, and the other one during the ongoing construction project. Okay, so typically construction project ni involve many stages of operation. Okay, so it is appropriate to evaluate and screen the project schedule of individual construction operation in order to determine in advance dia punya noise prediction. Okay. Sebab most of the situation, dia punya construction operation most are likely to produce greatest noise at a particular sensitive receiver, especially construction site yang memang close or located nearby to the residential area. Okay. Specific construction operation that need noise monitoring also can be identified. Okay. So that's the purpose of the noise level measurement. Right? Next we have this one. A continuation, mesti dia punya description lagi untuk during the construction. Maksudnya measurement during the construction. Okay, so this one usually sensitive receiver lah. Sensitive receiver selalunya boleh jadi resident dekat perumahan, student ataupun pelajar sekolah. And then kalau that proposed site ataupun that construction site located close to the hospitals or any bullshit area, so most of the time they are affected by the pilots ataupun any substructures activities, site clearing, earthwork and so on. Okay, sebabnya most of the, based on previous study, this kind of activities generate the most ataupun the highest construction noise. Okay, pilot activities and excavation may have significantly greater potential. Okay, so that's why we need to properly measure and manage the noise during the stages of construction. And noise generated from this operation, for example, piling and earthwork or excavation, can be measured and compared to permissible noise limit by DOE. That's the main reason lah why we need the noise level measurement. Okay, so that we have the measured value, and then we can compare with the existing or permissible noise limit by the Department of Environment. Alright. And dia juga sama penting or equally important to measure background noise at various intervals during construction phase. So meaning that kita kena keep on monitoring, keep on measuring the background noise as the construction progress. Okay. Okay, so far here we have covered on noise level measurement, both for planning stage and also construction phase, construction stage. So, boleh faham Okay ke semua?
Betul.
Alright. So, masing-masing kat rumah ke ada yang tak kerja kan hari ni? Juga.
Betul.
Macam mana? Keputusan.
Dekat office.
Oh. Okay. Right. So, hopefully so far inilah kita dapat faham dia punya in terms of the gist ataupun dia punya main idea for construction noise management. Okay. Before we continue, okay. Next, let me proceed je lah to noise level assessment. Okay, the other thing related to noise level, just now noise level measurement, sorry. So this one, noise level assessment. Okay, for the assessment, there are two main components that we need to know, we need to assess. The first one is noise level gain. Berapa dia punya increment, especially the increment in terms of noise level. And then the next one we have noise impact. Okay, apa dia punya potential impact ataupun anticipated ni lah, community response, right? So for the first component or criteria for noise level assessment, what we call dia punya, as we know, subpressure levels, if there are increment, okay, if there is increment or increase of some pressure level, it will affect human reaction. Okay. So kita akan aware, kita akan rasa affected once there are increment in subpressure level, especially the increment is quite high. Okay. So it is mentioned that an increase by 3 decibel is very detectable by human ears. So for example, kita ada sound pressure level of 50 decibel EVA, elevated, and due to the activities, for example construction activities, the what we call existing soft pressure level only increased for about 53 or 52. Okay, so this increment is actually not really significant, which is barely detectable by human ears. Okay, however, if we have recorded 10 decibel increment, that one will be perceived by human ears, and we can consider it as double of the sound. And in terms of dia punya effect, it's very irritating or it's very significant and affected the receiver ataupun ni lah nearby community or anyone who exposed to this noise level. Okay, so that's for noise level gain. Saya akan tunjuk juga dia punya table related to noise level gain. And then the other component is noise impact. Okay, so maksudnya this is the relation based on the measurement, okay, noise level measurement. Then the next step we do the noise level assessment. Okay, we try to assess, we try to evaluate the noise level, how severe or how bad is the condition. Kalau excessive noise level, we try to assess all the related component lah. Okay, untuk noise impact kita akan tengok noise impact assessment and also dia punya anticipated community response. Okay, for example, kalau tadi daripada 50 decibel A, this is just example. Okay, dia maksudnya dia punya existing level and suddenly there is significant changes of increment for 60 decibel or more. So this one will be significant changes of the sound. So kita can further assess or further evaluate in terms of the impacts and also response by the community. Okay, so the assessment or assessed noise level is known as rating sound level. So we just simply call it as LR. So based on this rating, kita akan tahu dah dia punya impact of the assessment, impact of the noise assessment, which includes the correction for the sound characteristic to the measured noise level. So nanti saya akan share berkenaan rating sound level LR. Okay. The next one we have ni yang saya cakap example of noise level gain. Dia punya tak clear kat dia table ni. Okay, so untuk noise level gain, dia ada dia punya several types of category. Okay, for example, and each of these gain ada dia punya description lah. So if the gain ataupun increment 0 or less than 0, so that one will negative lah. So tak ada, memang totally not significant, totally insignificant. Kalau 0 to 3 still insignificant, as I mentioned, it's barely detectable by our ears. And kalau ada any changes 3 to 5, it will be considered as small gain or small increment. And proceed with 5 to 10, we have medium noise gain, and ini is mentioned just now, 10 or more, but still less than 50. It's significant, yes, but category of strong. And we have the other one, which is very significant or strong, if the changes is, the increment is more than 50. Okay, more or equal than 50. So this one is very severe lah, severe condition, which may affect the anyone who is exposed to that excessive noise. Okay, so that one in terms of noise level gain. Alright, the next one, noise impact. Okay, tadi dah tengok satu, the first component, noise level gain, and then the other one we have noise impact. Okay, untuk noise impact ni, both of these nanti kita akan guna pakai lah dalam kita punya ni. Try to relate with the application. Okay, untuk noise impact, as I mentioned previously, it's related to the rating sound level, which is LR. So dekat LR ni, the information that we need is LEQ. We get LEQ for the certain construction activities, and then plus the kalau ada apa orang panggil karakter, yang ni lebih kepada karakter bunyi itu sendiri. So kalau ada this one, kita kena consider or include in the relation. And then we need to minus the percentage of the duration fraction. Okay, so yang ni lebih pada percentage. So LEQ, for example, kita ambil balik tadi 50 decibel A. And kalau ini dekat certain point tu atau certain sound tu involved dengan impulsive noise characteristic, for example, piling activities. So we need to consider this correction value. So we need to macam sebagai contoh 50 LR equal to 50 plus 5, and then tengok duration. Duration ni refer kepada duration of the individual activities lah. Macam kalau kat sini piling, so kita kena tahu dia punya percentage of the individual machineries tu bekerja berapa lama. For example, dia punya duration is on berapa persen kita ambil kat sini apa? Palingnya 18.6 ni kan. So, kita kena ada reduction. Okay, reduction. Right. So, kita kena ada. Jadi, tolak, sorry. Minus duration. Duration, kalau yang ni negatif. Okay, so at the end, kita akan dapat 5 plus, so 65 lah. Dia punya sound level rating, rating sound level. Okay, that's a simple example for sound level rating. Okay. Okay. So saya akan continue to the next one. Okay. Continue to the next. Ini still on noise impact. Dia ada pula dia punya delta of ataupun changes of tadi apa sound level rating atau rating sound level. Dia ada different changes. How we measure or calculate the changes is that kita ambil tadi LR. Okay, LR kita dah measure di sini. For example, in this case, 65, right? 65 decibel. And then L90. Ada siapa-siapa ingat ke L90 ni apa? Ini kena ingat maksudnya at least senanglah untuk solve the calculation. L90 refers to what? Boleh recall tak? Ada. Tak apa. So L90 ni akan refer kepada ambient noise level ataupun background. Okay. So kita most of the time kalau kita tengok pada kalau contoh in case kita nak jawab soalan, usually dia ni lah it's already given the level for ambient noise. Contoh for example kita ambil 45, sometimes dia common background noise level adalah 50. So kalau dia dah mention this specific value, just apply to the formula lah. Okay, 45 or 50. Alright. So kalau
Doktor, nak tanya yang 90 ni refer to yang semalam tu doktor.
betul, background noise level.
Yang doktor mention refer to on DOE 2019 balik tu
Betul. Sebab dekat guidelines DOE pun dia dah outline ni L90
mention kan. Nak tanya, macam doktor bagi 45-50 ni, ini given ke atau nak guna refer table?
Oh, yang ni 45-50 ni common kalau based on measurement, actual punya condition.
Punya condition?
Contohnya sebelum ni saya dah pernah buat measurement dekat residential area. So kebanyakan kita punya common level adalah 45 hingga 50 lah. Maksudnya kalau dia tak ada involved dengan heavy heavy noise sources, ni adalah common punya ambient 45 atau 50.
Oh, tak perlu guna yang, kita tak perlu guna yang maksimum ni lah.
Yang maksimum tu sebenarnya tu limit. Apa orang panggil? Tu dia punya permissible limit lah.
Kita tak perlu tak perlu guna limit ni lah.
Dia macam ni. Sebenarnya purpose kita buat measurement, kita nak cuba compare dengan yang limit tu tadi. Faham tak?
Okay, faham. Maknanya kita tak boleh exceed this limit lah.
Betul, tak boleh exceed the limit. Kalau dia dah outline, contohlah kan saya tak ingat juga dia punya residential punya limit. Contoh dekat guidelines tu berapa, contoh kita ambil dia 50 lah kan. 50, sekali kita measure dia punya actual measurement punya reading 45. So that one still okay lah dia punya limit.
Okay.
So that one lebih kepada comparison lah between measured value and permissible limit. Okay. So ni just example lah 45 dan 50 ni. So kita include the inequalities, kita include in the calculation. So contoh kat sini 65 tolak dengan 45 lah kita ambil So the reading will be 20. So 20 ni sebenarnya macam dia quite tinggi lah sebenarnya. Dia punya in terms of this one. Okay. Lebih daripada 15 ni. So the noise level gain ataupun dia punya impact is very strong. That's the relation lah kat sini maksudnya. Okay. So boleh faham so far? Right. Okay. So kalau faham, saya akan proceed lagi sebab yang part 3 ni tak berapa banyak dah sebenarnya. So actually part 3 for this third part ni, part ketiga kita, sebab saya rasa maybe kita boleh terus combine dengan calculation. Calculation pun as long as kita tahu dia punya main requirement ataupun main component, dia lagi senang lah untuk kita proceed with the calculation. So later saya rasa untuk session kita yang sekarang ni, saya try to merge part 3 and part 4 so that maybe evening session nanti kita tak ada kelas lain. Kita adalah terlalu ni pack sangat. Okay. Okay ke kalau merge?
Tak, Doktor, saya nak tanya sebenarnya. Nak dengan noise level ni. Noise level ni memang untuk public saja
Maksudnya public macam mana?
Maksudnya macam sekarang ni doktor kata kita punya sound level punya equipment tu, kita akan counter balik dengan dia punya level punya permissible kawasan tu kan. Meaning that untuk public sajalah. Kalau macam untuk equipment apa semua tu tak boleh
Oh, maksudnya kita nak check balik dengan equipment tu?
Equipment yang level tu macam saya banyak pasang kat logi apa semua tu. In term of dia punya
individual machine tu. Oh, yang tu boleh juga, cuma kalau guideline daripada DOE ni dia memang untuk community noise lah, environmental noise.
Maksudnya untuk community sajalah. Terlibat dengan macam nak counter dengan kilang ke apa kan. Kata you punya mesin bising ke, tak boleh lah.
Oh, yang mesin bising tu kita akan refer kepada ni lah guidelines yang daripada British Standard tu. Okay, British Standard tu dia dah outline dia punya apa? Certain level of the individual sound power for each panggil macam compressor, generator.
Betul.
Yang tu ada dalam BS, British Standard. Kalau yang ni memang kita kena ingat lah, yang ni based on DOE, dia memang fokus kepada environmental noise. Okay. Kalau compliance untuk macam contoh kat kilang lah, senang kita ambil contoh kat kilang, yang tu dia dah fall ada kategori heritage dan occupational, kepada pekerja tu sendiri. Betul ke?
Kalau untuk pekerja tu tak termasuk inilah.
Tak, yang ni memang environmental noise. Yang pekerja dia panggil occupational noise, yang macam saya dah share semalam. Sebab kita kena identify sebenarnya. Contohnya sekarang kita fokus dekat environmental noise ataupun construction noise ni lah. So, the right guidelines ataupun dia punya reference adalah kepada ni lah, guidelines by DOE. Okay. And then kalau untuk occupational noise, maksudnya dia punya effect dekat workers, in terms of dia punya individual, apa tadi, level untuk machineries itu sendiri, kita akan refer kepada selalunya OSHA and FMA. Okay.
FMA 2.
Boleh faham ke?
Faham sikit-sikit lah. BS yang doktor sebut tu BS yang 5228 ni
Betul. BS 5228. Right. So memang BS 5228 tu memang main, memang apa orang panggil, main punya reference untuk DOE juga. Tapi dia yang tu sebab dekat BS dia very comprehensive. Dia ada dia punya part of the standard berkait dengan environmental noise, and dia ada part dia dah list dia punya database untuk individual machinery. Okay.
Tapi calculation ni sama macam doktor bagi ni lah.
Macam mana equation?
Dia punya calculation tu and noise semua tu.
Kalau yang ni memang fokus untuk environmental noise sahaja je lah.
Okay. Terima kasih.
Alright. So as long as kita boleh differentiate jenis noise tu, so later on kita boleh pakai ni lah, right, guidelines ataupun any regulation ataupun atau. Okay. Sebab
Kejap tambah lagi. Tanya lagi. Kalau tadi doktor kata pakai BS untuk site punya, say saya punya mixer truck ke apa kan?
apa? Contoh?
Mixer.
Mixer.
Truck bising kan? Benda tu involve dengan public ke?
Public
maksudnya dia kan akan lalu jalan raya kawasan-kawasan tu kan? Itu terlibat dengan public juga ke?
Kalau yang tu sebab ni mixer yang tu ke simen punya lori tu ke?
Simen punya lori ke?
Sebab kalau ikutkan yang tu macam ni, dia still environmental, tapi dia lebih sebab dia on road kan, jalan.
Betul.
Memang yang tu kalau ikutkan dia dah contribute to the whole traffic noise lah. Okay.
Maksudnya public still boleh komplain lah.
Kalau berkenaan traffic noise masih boleh, sebab traffic noise pun dia ada dia punya limits juga. Boleh yang tu, boleh komplain, cuma kena apa orang panggil, kaji balik lah sebenarnya apa dia punya punca, maksudnya apa dia punya sources tu. Tapi kalau mixer, once dia dah masuk kat site dan benda tu pun memang dia bekerja dekat site,
itu kita punya lah.
Betul, itu construction noise lah.
Okay.
Sebab focusing kita tengok kita punya scope ataupun kita punya limit area tu. Okay. So kalau within construction site, so for sure that one generated due to construction activities, and kita categorize dia sebagai construction noise. Okay.
Sebenarnya tu bawah kita orang punya obligation lah, kena settle benda tu.
Macam mana kena settle?
Kalau dalam site tu maknanya kita orang punya obligation lah, kena settlekan isu tu.
Betul.
Kat jalan tu dia orang punya lah.
Betul.
Okay. Betul.
Alright. Okay, so tadi kita dah sampai mana tadi? Ni. Changes of sound level rating. Okay, kat sini kita boleh tengok lah based on this assessment, based on this measurement, ataupun calculation ni kita tengok dia punya impact ataupun di level. Kita dapat tahu level lah, based on calculation kita dapat tahu level, and then based on the level kita cuba compare dengan available limits, kita boleh categorize dia punya how severe the impact is. Right? Okay. So noise impact sama juga. Okay, ni yang tadilah rating sound level tadi. So kalau dah ni exceed this 20, dia very strong, and then dia punya impact adalah vigorous community action. So selalunya vigorous ni memang resident tu sendiri for sure akan dah complain kepada local authorities, complain to any respected parties lah. sebab dia punya impact very strong. So yang ni yang kita anticipate ataupun yang kita predict. Okay. So that during the actual construction, kita cuba mitigate ataupun avoid this kind of situation. Alright. So just now saya mention pasal apa, part 3 and part 4 kita terus merge, okay? Boleh ke nanti? Sekarang 11.30.
Maksudnya terus sambung doktor kan?
Betul. Boleh ke?
Maknanya kita akan habis pukul 12 lah.
12. Kenapa tak? Boleh ke?
Boleh. Dari awal lah maksudnya.
Maksudnya paling tu pun sebab sekarang setelah subuh kita tengok berapa lama kita punya discussion on calculation. Yang tu sebab dia tak terlalu panjang tapi kita still kena tahulah dia punya step. So maybe paling tu pun 12.30 pun.
Seronok agak macam tu doktor.
Before pukul 1 lah.
Boleh.
Before pukul 1.
Okay doktor.
Right, so macam apa ni? Lagi suka kan? Okay, tak apa. So hopefully the rest of you pun okay lah. Sebab saya difahamkan pun malam nanti pun akan ada meeting semua kan. So adalah masa untuk rehat. Okay, cuba digest all these part ataupun subtopik ni lah. Sebab kita quite compact sebenarnya kan. Daripada semalam dah 2 session and then continue to the session. Okay, so tadi dah sampai nurse level assessment. And then yang ni yang saya cakap databases tu. So far in terms of databases, kalau kita tengok there are 4 main category lah kat sini. DEFRA ni Department of Environmental, Food and saya tak ingat dah dia punya full name. Tapi yang saya dah mention semalam dia punya. So dia dah establish juga dia punya data regarding the individual databases related to the construction juga and sub-activities. And then dekat BS pun kita boleh refer. Okay, yang ni lagi detail. Kalau compare 4 ni BS lah dia banyak lagi comprehensive. And dia punya data integrate juga daripada data untuk dia punya historical data and current data CD and HD. Okay. Historical data based on data and CD based on dia punya current research. Lepas tu untuk kita punya local scope kita ada juga actually tapi it's very limited sebab sebelum ni saya dah mention kat Malaysia kita masih lagi dalam stage yang research, conducting the research, try to collecting related information. So the available data, existing data is quite limited, right? As compared to the other countries lah. But still, we have compiled some of the data based on the relevant research, okay, including the model type and net install power of the individual machineries. Okay, and the other thing by the other department is Federal Highway. Okay, yang ni Federal Highway Association FHWA pun dia ada compile dia punya own data tapi specifically for the equipment and operation involved for the highway construction. So kita untuk kita punya local scope ataupun local punya data still need lah more compilation, okay, so that kita ada very comprehensive reference. That's regarding the sound level database. Alright. The next one we have this. This actually the example. The example extracted from BS. Okay, BS punya data quite comprehensive. Dia dah list out each of the related equipment. Okay, sini based on the construction activities punya ni. Stages, clearing site, ground excavation and work. So they dah list all the required instrument with the power rating and its capacity. Maksudnya memang quite comprehensive. So dia ada juga dia punya data based on the frequency punya reading. So yang ni wanted lah, wanted a different. Kita tengok kat sini for each of the frequency dia ada juga dia punya some pressure level at 10 meter. Okay. And this one equated the total combined some pressure level. Okay. So far that's all for this third part, part 3, berkenaan construction mass monitoring, measurement and treatment. Saya tak ada dah. Sorry, 11, apa ni? 11, 12 senang. So, ada apa-apa soalan tu untuk part 3? Ada question? Sebelum kita continue with the last part, which is part 4, focusing on the calculation. Bila rehat kejap. Boleh ke? Boleh.
Boleh, doktor.
Alright. So that's all for part 3. Kalau ada apa-apa soalan later on berkenaan part 1, 2 or 3, kita still boleh tanya and kita sama-sama discuss. So kita akan, as for now, we will have short break. Maybe 10 minutes, okay? 10 minutes for the break, and then we continue for part 4. Right? So that's all for part 3.